Okay, today's lesson is about rational and irrational numbers. Today's lesson is really just a vocabulary lesson. I am not going to be testing you over vocabulary, so if ever there comes a time that you see a word that you don't remember its definition, please just ask me, even if it's on a test day. But I'm just going to show you some words that will get used in a math class often, and eventually you will pick up on what the words mean, but don't spend a lot of time trying to memorize these definitions. Okay, so a rational number is a number that can be written in the form P over Q. P and Q are integers. Remember, integers are positive or negative whole numbers and zero. This says that your denominator cannot be zero, though. That's what that says. So it says all fractions, both positive and negative, are rational numbers. And just these are your examples. Could be anything, but those are just some examples that are given. Okay, on this page it says write each as the ratio of two integers. Well, it really is just as simple as negative 15 can be written as a ratio of two integers by simply placing negative 15 over 1. That's all you have to do to this. On part B, you have 6.81. That's the same as 6 and 81 1/100ths. But because we want a ratio of two integers, we want to turn this into an improper fraction. So 100 times 6 is 600 plus 81 is 681 over 100. Okay, and on part C, we have negative 3 and 6/7. So just turn that into an improper fraction. So 7 times 3 is 21. 21 plus 6 is 27. Don't forget your negative sign out front. Denominator is 7. Okay, so this one says that irrational numbers, an irrational number is a number that cannot be written as a ratio of two integers. And its decimal form does not stop and does not repeat. So that's what you have to look for the decimal. It's going to be just a bunch of numbers and there is no pattern. You cannot find a pattern to their decimal. So that's going to be an irrational number. Okay, on part A, so it says identify each of the following as rational or irrational. Remember, irrational numbers do not have a repeating number or a pattern of any sorts. So in part A, notice how you have a repeating 3. So that means that this is rational. Notice how in part B we don't have any dots after the 5, so that means that this does stop. It does not keep going on forever. So this one is also rational. And on part C, notice how you have the dot at the end. That means that the decimal still goes on. And it does not appear that there is a pattern. Even though you see the 5s, 3 in a row, after that you don't see a pattern. So we're going to call this one irrational. Okay, to identify these as rational or irrational, I can take the square root of 36. The square root of 36 is 6. That means that the square root of 36 is rational. The square root of 44, if I were to type that into my calculator, I get 6.633249,581, and I'm assuming it goes on, and I don't see any pattern there, so that means this is irrational. Okay, so this page is just showing you that irrational numbers are their own beast. They're over here on the right side. They do not encompass any of these other terms. So with counting numbers, 1, 2, 3, 4, 5, whole numbers, you're going to include 0 in there. With integers, you're including all of your whole numbers plus counting numbers, as well as the negative whole numbers. And then rational numbers includes all of these things. But irrational, off on its own. Okay, so for this page, we are going to determine whether each of the numbers in the following list is a whole number, integer, rational number, irrational number, and a real number. And so the easiest way, honestly, to show you this is I'm going to show you the table that goes along with this. And you might want to just take a look at the table. Again, don't try to memorize anything. Just take a look at it and try to understand the terms that go with each of these numbers. Okay, so take a look at this table. So -7 is not a whole number because it's negative, okay? Whole numbers include the positives and 0. It is an integer because it doesn't have a decimal and it is negative. It's rational because we can write it as something over 1. It is not irrational. Notice how the rational column and irrational column, it's either one or the other. It can't be both. And it is a real number. We haven't really talked about real numbers, but a real number is something that is not imaginary. So if you take the square root of 4, you get something that makes sense. You get 2. But if you take the square root of a negative number, that's when you start getting into imaginary numbers, and that is beyond the scope of this class, but I just want you to know that there is such a thing as imaginary numbers. Okay, so this one explains just a little bit better, probably better than the words that I can put it into. And again, I don't want you to try to memorize any of this. Just try to wrap your brain around it and try to understand the vocabulary that goes along with this lesson.